Everything you know, everything you've ever seen, every person you've ever loved, exists on a tiny, fragile world we call Earth. Our planet is a member of a solar system, which itself is just one of countless star systems swirling within the Milky Way galaxy. Our galaxy is a single island of light in a vast cosmic ocean, home to hundreds of billions of other galaxies. This grand tapestry of existence, this universe, had a beginning. It wasn't always here. About 13.8 billion years ago, all the space, all the matter, and all the energy we can observe was compressed into an unimaginably hot, dense point. We call this moment the Big Bang. It wasn't an explosion in space because space itself didn't exist yet. It was the explosion of space everywhere, all at once. The universe was a seething soup of elementary particles. As it continued to expand and cool over thousands of years, these particles could finally come together. Nuclear fusion ignited in their cores, and the first light blazed across the cosmos, ending the cosmic dark ages. These first stars lived fast and died young, forging heavier elements in their hearts and scattering them across space when they exploded. Elements like carbon, oxygen, and iron, the very stuff you are made of. We are stardust. We are the universe made manifest. In the 1920s, an astronomer named Edwin Hubble made a revolutionary discovery. He observed that distant galaxies were all moving away from us. This wasn't because we were at the center of some great cosmic exodus. It was because the very fabric of spacetime itself is expanding. Imagine baking a loaf of raisin bread. As the dough rises, every raisin moves away from every other raisin. From the perspective of any single raisin, all the others appear to be rushing away. For a long time, cosmologists thought there were two main forces at play in this cosmic drama. On one side, you have the initial outward push of the Big Bang. On the other side, you have gravity, trying to slow that expansion down. But then, in the late 1990s, astronomers studying distant supernovae found something astonishing. They expected to see the expansion slowing down. Instead, they saw the opposite. The expansion of the universe is accelerating. It's getting faster and faster over time. Something is pushing space apart, overwhelming the pull of gravity. Scientists have given this mysterious force a name: dark energy. We don't know what it is, but it seems to make up nearly 70% of the universe. This discovery changed everything, opening up new and more dramatic possibilities for how our cosmic story might end. Let's explore the first scenario for the end of the universe, and perhaps the most widely accepted one today. It's called the Big Freeze, or sometimes the heat death. In this future, the mysterious force of dark energy continues its relentless work, pushing galaxies farther and farther apart. The expansion never stops. In fact, it continues to accelerate. Imagine standing in our Milky Way galaxy trillions of years from now. When you look out into the cosmos, you will see nothing. All the other galaxies will have been pushed so far away that their light can no longer reach us. Within our own local group, galaxies like Andromeda will merge with our Milky Way to form one giant super-galaxy, which we could call Milkomeda. As the eons pass, the era of stars will come to an end. The last, small, red dwarf stars, which sip their fuel so slowly they can live for trillions of years, will finally flicker and die. The universe will be plunged into darkness, populated only by the stellar corpses left behind: white dwarfs, neutron stars, and black holes. The temperature everywhere will approach absolute zero, the coldest possible temperature, where all atomic motion nearly ceases. There will be no heat, no light, no life. On timescales so vast they make the current age of the universe seem like a fleeting moment. Even these stellar remnants will decay. The universe will become a cold, dark, and empty void, expanding forever in an eternal, silent twilight. What would this big freeze future feel like for a civilization like ours, if we could somehow survive for that long? In the near future, say a few billion years from now, life on Earth would already be impossible. Our own sun will eventually run out of hydrogen fuel in its core. It will swell into a red giant, its outer layers expanding to engulf Mercury, Venus, and almost certainly Earth. But let's imagine humanity escapes to another star system around a longer-lived star. For a while, things might seem normal. Our descendants could hop from star system to star system within our Milkomeda galaxy. But the view would change dramatically. The night sky, once sprinkled with the faint smudges of distant galaxies, would grow darker. One by one, those galaxies would wink out of existence. As the last stars begin to die out, a profound energy crisis would set in. A civilization's ability to do anything, to think, to build, to live, depends on harnessing energy. Without them, any surviving intelligent life would have to become incredibly resourceful. Life would become a desperate struggle for the last remaining pockets of warmth and order in a universe sliding inexorably toward maximum entropy. Now let's rewind the clock and consider a different fate, one that was the leading theory for much of the 20th century. This is the Big Crunch. In this scenario, dark energy either doesn't exist or it's much weaker than we currently think. Instead, the force of gravity is the undisputed champion of the cosmos. At some point in the far future, the expansion would slow to a halt. The universe would reach its maximum size, pausing for a cosmic breath. The galaxies would hang motionless in space for a moment. Then, slowly at first, and then with ever-increasing speed, gravity would take over completely. The expansion would reverse into a contraction. The universe would begin to fall back in on itself. As space contracts, the galaxies would get closer together. The night sky would become brighter and more crowded. The temperature of the entire universe would begin to rise. As the contraction accelerates, the background temperature would become hotter than the surfaces of stars. The stars themselves would begin to cook from the outside in, eventually exploding. The atoms that make up planets, stars, and even our bodies would be torn apart. The universe would revert to the hot, dense plasma soup it was in the first moments after the Big Bang, finally collapsing into an infinitely hot, infinitely dense singularity, the Big Crunch. What would this cosmic collapse feel like for any inhabitants of the universe? The first signs of the end would be seen in the sky. Astronomers would notice that the redshift of distant galaxies was decreasing. For billions of years, life might continue relatively normally as space slowly began to shrink. But eventually, the changes would become impossible to ignore. The sky would blaze with the light of approaching galaxies. As the universe contracts, the ambient temperature of space itself would rise. First to a balmy room temperature, then to the boiling point of water, and then far, far beyond. The universe would become an oven. Any advanced civilization would need to find a way to shield itself from this ever-increasing universal heat. It would be an engineering challenge unlike any other, trying to create refrigeration against the heat of the entire cosmos. The end would come swiftly and violently. Stars, once separated by light years, would be packed closely together. Close encounters and collisions would become common. Finally, in the last moments, even subatomic particles would be destroyed. The forces of nature would merge back together as the universe returned to the primordial state it was in before the Big Bang. But this ending holds a tantalizing possibility that the others do not. Some physicists have speculated that a Big Crunch could lead to another Big Bang. This is the idea of a cyclical universe, or the Big Bounce. Our universe could be just one in an eternal series of universes, endlessly expanding and contracting, born from the ashes of the one that came before. There is a third and perhaps most dramatic potential ending to our universe. This one depends on a particularly aggressive form of dark energy, sometimes called phantom energy. What if the density of dark energy actually increases as the universe expands? This would create a runaway effect. The more space expands, the more potent dark energy becomes, which causes space to expand even faster. This vicious cycle leads to an end known as the Big Rip. The accelerating expansion becomes overwhelming. It's no longer just pushing distant galaxies away from each other. The force becomes so powerful that it starts to overcome the fundamental forces that hold things together. About 60 million years before the end, our own Milky Way would be dismantled. Its beautiful spiral arms would be unwound, and its billions of stars would be flung into the rapidly expanding void. About 3 months before the end, the expanding force would become strong enough to overcome the sun's gravity, and the planets of our solar system, including Earth, would be ripped from their orbits. Minutes before the end, the Earth itself would be destroyed, its own gravity insufficient to hold it together. The planet would explode. In the final fraction of a second, the electromagnetic forces holding atoms and molecules together would fail. Your body would be torn apart, atom by atom. Finally, even the atomic nuclei would be ripped apart. The fabric of spacetime itself would tear, ending everything in an instant. Let's try to imagine the final day from the perspective of someone on Earth, assuming our planet had somehow survived until this point. The signs would have been clear for millions of years. In the last few months, the solar system itself would become unstable. The gravitational glue holding our celestial family together would weaken against the ever-stronger push of dark energy. We would watch as the moon, our constant companion for billions of years, was torn from its orbit and sent flying into the darkness. Then Jupiter, Saturn, and all the other planets would follow suit. The final hour would be the most terrifying. Earth would be a rogue planet, tumbling through an unnervingly empty space. About 20 minutes before the final rip, the Earth itself would succumb. In the final fleeting moments of existence, the rip would come for the smallest things. Your very body would be torn apart. The chemical bonds holding your molecules together would snap. Then, in the last 10 to the negative 19th seconds, the atoms themselves would be ripped asunder. The universe would end not in cold or in fire, but in a complete and total disintegration of matter itself. We've journeyed to the furthest reaches of time, exploring 3 possible fates for our cosmos: a cold, lonely big freeze, a fiery, recycling big crunch, or a violent, sudden big rip. Right now, based on our best observations of the accelerating expansion, the big freeze seems like the most probable outcome. But we must remember that our understanding is incomplete. The nature of dark energy remains one of the biggest mysteries in all of science. Is it constant? Does it change over time? Will it one day fade away? The answer to that question holds the ultimate fate of the universe. This exploration isn't just an academic exercise. It's a profound reminder of our place in the cosmos. The fact that we, collections of stardust on a small planet, can even ask these questions is a testament to the remarkable power of the human mind. We are the universe's way of knowing itself. The laws of physics that govern the birth of stars and the death of galaxies are the same laws that operate within us, that allow you to read these words and to ponder their meaning. Thinking about the end of everything can feel overwhelming, even frightening, but it can also be liberating. It puts our own lives, our worries, and our triumphs into a grand cosmic perspective. The universe has been here for 13.8 billion years and may go on for trillions more. Our lives are but a brief, beautiful flicker in that immense expanse of time. This knowledge doesn't have to make us feel insignificant. Instead, it can make every moment feel more precious. It highlights the incredible improbability of our existence and the extraordinary opportunity we have to experience, to learn, and to wonder. So I leave you with a question. As you stand under the canopy of the night sky, a citizen of the cosmos, what do you think? Which future feels most plausible to you? Does the idea of a quiet big freeze resonate? Or does the cyclical nature of a big crunch offer a kind of hope? Or does the dramatic finality of the big rip capture your imagination? There is no right or wrong answer. The story of the universe is still being written, and we are privileged to be here, for this brief moment, to read its pages and to wonder what the final chapter will hold. Your curiosity matters. Keep looking up.